All right, so this is going to be part 2 of our lesson on simplifying expressions with different kinds of exponents, including negative numbers and fractions. In part 1, we already did all these problems, 1 through 12, and so we're picking up here at number 13. All right, so I guess we'll do number 13 through 18 at least. All right, so looking at number 13, notice how the roots are the same. We would definitely go ahead and multiply these things together, put it under one roof. So if I do that, I'm going to have the cube root. Somebody help me. What is 49 times 7? 343. Okay, and then I'm going to have x to the 6th power. All right, so now I need to do the cube root of 343. And you can use your table, right? So cube root of 343 is 7. Okay, so I'm definitely going to get 7 right there. X to the 6th power. How do I do the cube root of x to the 6th power? You just divide. 6 divided by 3 is 2. So this would be your answer for number 13, 7x squared. Any questions on number 13? Okay, moving on to number 14. All right, this one's going to take a little bit more work, a little bit more preparation. Right, because these things are not perfect cubes, so I'm going to separate them into things that are perfect cubes and things that are not perfect cubes. So let's start with 1,458. Is that on the chart? No, it is not. Okay, so I need to find one of these perfect cubes that goes evenly into 1,458. Okay, so I'm doing 1,458 divided by stuff. All right, at the bottom of our chart there. All right, 729 is probably not going to work, but let's try it. Oh, it does work, actually. Okay, so that's what we're going to use. So we're going to use 729 and 2. Since 729 is on the chart. Everything that can be reduced, I'm going to write in pink. So I've got 729 times 2. Now, g to the 5th power. I need something that is divisible by 3. So yeah, let's just split it up as g to the 3rd power and times what? Times g to the 2nd, because together that makes 5 g's. Similarly, what will I do with the h's?
H to the 3, and just h, right?
H to the 3, and then just h. Okay, any questions so far? How I've prepared the problem? Everything in pink can now be simplified and brought to the outside of the radical. So what is the cube root of 729? Let's see. The cube root of 729 is 9. Okay, so that's going to make 9. And then for the g, 3 divided by 3 is 1. Same thing for the h. 3 divided by 3 is 1. So I've taken care of each of the pink things under my radical. So that just leaves the blue stuff. Cube root of 2 g squared h. So this would be our answer for number 14. Any questions on number 14? Okay. Now, number 15. Number 15 is a strange little problem, so I hope everybody's paying attention. If I were you, I would change this numerator to a fractional power. So the 3rd root is the same thing as x to the 1/3 power. So I've got x to the 1/3 power over x squared. Now, when you have a fraction, you subtract the exponents when you divide. So this would be the same thing as x to the 1/3 minus 2 power. All right, you subtract. Now, if you had a calculator, you could just put it in. But what if you don't have a calculator on the test? you should be able to do 1/3 minus 2 without a calculator. Look at it like it's a 2 over 1. And then make like denominators. So this would be like 3 and 3. So this would be like 1/3 minus 6/3. What's that? What's 1/3 minus 6/3? That's negative 5/3. Okay, so that brings us back to the problem. So this gives us x to the negative 5/3 power. Now remember, negative exponents do not give you negative numbers. What do they do? What does a negative power do? It makes it into a fraction, right? It's going to just drop you down into the denominator. So this is just going to be 1 over x to the 5/3 power. And then because the original problem was in radical form, I'm going to put this back into radical form again. Remember, this is power over root. 5 is the power, 3 is the root. So this would be the same thing as 1 over cube root of x to the 5th power. It doesn't matter whether you put the little 5 under the radical or outside the radical. It would be the same thing. But this would be your answer to number 15.
What about if the radical and the x and the 3 were all in parentheses and there's a 5 outside of the parentheses? Would that be a different value?
Like if you had 1 over and then you had radical x and then you had the 5 like that, that would be the same thing. All right, equally good. All right, any other questions on number 15? All right, how about number 16? Are these perfect cubes, 27 and 512? Let's see. There's 27, there's 512. All right, so all you have to understand then is 1/3 power is the same thing as a cube root. So you don't really, there's really no work to show on this. I'm going to show it just to make it extra clear, but you should do this in your mind. You should just understand that 1/3 power is the same thing as a cube root. So we really are just doing the cube root of both of these things. All right, so what's the cube root of 27? That's 3. What's the cube root of 512? 8? Let me just double check. Cube root of 512 is 8. So that's it. That's the answer, number 16, is 3/8. Questions? Okay, number 17. First of all, let's take this one piece at a time. When I do negative 3 to the 3rd power, is this going to give me a positive number or a negative number? It's going to give you a negative number because it's an odd power. The negative stays. What is that number anyway? You know what? I changed my mind about how I want to do it. Let's do it this way. If I had n to the 3rd power times n to the 5th power times n to the negative 4th power, what would I do with all these exponents? We'd add them, right? So this would make n to the, let's see, 3 plus 5 is 8, minus 4 is 4. That would make n to the 4th power. You would just add. Well, guess what? You could do the same thing, even though it's a negative 3 is the base. Still, we have like bases, we could add all these powers. So this would make negative 3 to the 4th power. Okay, now, is the net result of this going to be positive or negative? It's going to be positive because I have an even power. Even power is going to turn everything positive. So what's 3 to the 4th power?
81.
81. So this is going to be 81, positive 81. Okay, just add the exponents. All right, and I think this will be the last one on this video. Are these both perfect cubes?
Yes.
Okay, if these are both perfect cubes, then is this possible? I've got a negative under this radical. Is this going to even be possible? Yes. because it's odd. You can do the odd root of a negative number, no problem. You just can't do even ones. You can't do like fourth root or sixth root. But this one we can do. So it'll just be a negative answer is all. The cube root of negative 64 is 4. The cube root of 125 is 5. So it'll just be negative 4 over 5. Okay, any questions on number 18? By the way, if my colleagues are silly enough to let you use a calculator on this test, I do want you to understand how to take the root of things on your calculator. For example, if I wanted to do the fourth root, say if I wanted to do the fourth root of 81, like this. All right, say if I wanted to do this on my calculator. Everybody practice this with me. You would type in your 4 first, and then you would hit second caret, and then that turns into the fourth root. So you could do the fourth root of 81 like that. Okay, it gives you the same value as your table. Now with that in mind, if my colleagues are silly enough to let you use a calculator, you could have typed in this entire problem into your calculator. Okay, so let's try that. Try typing in this whole problem in your calculator. So I'm going to do the third root of this fraction. That's not my calculator. All right, so if I want to do the third root, first I put the 3. And then I hit second caret. Now I've got the third root. It was a fraction, so I go into fraction mode. In the top, it was negative 64. In the bottom, it was 125. Boom, just gives you the answer. Okay? So I'm really hoping my colleagues are not silly enough to let you use your calculator, because what's the point? Okay? All right, that's going to be the end of this video.